In this video, we will learn about probability models. Probability models is something where you will have certain data in terms of table or other ways. You will be given a lot of data already, and then they will ask you to find out whatever other things are required. Or in this case, you can see there's an unknown in the table itself. Let us see how do we solve this. It is again another basic topic, but once you understand one problem, then the other problems will be very easy. Now over here, the probability that a randomly selected person has 0, 1 or 2 dogs are shown in the table below. You can see number of dogs, 0, 1 or 2. The probability that a person randomly selected has no dogs is 35% or 0.35, whereas that person has one dog is 0.15 and having two pets will be 0.2. Now we need to find out for 3 or more. So now let's see what are the questions that have been asked. What is the probability that a randomly selected person has 3 or more dogs? Enter your answer as decimal. Now over here, we will just focus on 3 or more. That is this main thing, 3 or more would mean whatever other than this. So whatever more than this. It can be 4, 5, 6, anything. And one more question over here is, what is the probability that a randomly selected person has at least one dog? So at least means it can be 1 or 2 or 3 or 4, but minimum 1 must be there. So it can be any number. So it is more than, greater than or equal to 1. So now let's solve them one by one. The solution for the first part. Before we find this in particular, we will just write the total probability. One important thing that you must remember is whenever you add all the probabilities, it must be equal to 1. So what does this mean exactly? So now whenever you're doing an experiment, say now there are 52 cards, okay, you will be picking one card. So there is one card that will be picked no matter what. So if I add up the probabilities of all the cards, each card is very low probability that will be picked. So it'll be 1 by 52. If I add it, the next card is again 1 by 52. So I have to do it 52 times. Ultimately, I'll get 52 by 52. That is 1 or 100%. So what it basically says is whenever you have values like this, whenever you add up all the values, the probability must be equal to 1. So what is the total probability? It is 1. The probability of 0 dogs is 0.35, 1 is 0.15, 2 is 0.2, and this is unknown. But that is fine. Why? Because we can find it now. So all you need to do is take everything to one side and then solve it up over here. So you will get 1 minus 0.35 minus all these three terms. That is equal to probability of 3, and the answer is 0.3. So 30% is the probability that a randomly selected person has 3 or more dogs. Over here it is, 3 or more. So that is it. Now, since over here in this table it is not mentioned, we just are taking this, but it is assumed that it is, even if it's more than that, this is the probability. Now, what was the next one? What is the probability that a randomly selected person has at least one dog? So over here, there are plenty of ways to solve it. One way would be very simple. So more than one dog would be 1, 2, 3, and so on, right? So you can just do 1 minus 0. So what does this mean? 1 minus probability of no dogs would give you more than 1. That's it. Or you can do another way. You can just add this probability 1 plus 2, this probability, and probability of 3, that is 0.3. You can add it up. 0.3 plus 2, 0.5, 6.5. 0.65 would be the answer. So you can either do like this, at least one dog would be 1 minus probability of 0, or you can add these three up and you will get the answer. So this is how you solve it. This is basically a probability model problem. Now we will see more problems over here. To pass a multiple choice test, Tom should not make more than one mistake. The table below shows the possible number of mistakes Tom can make along with their corresponding probabilities. So if Tom has to pass this mistake, he can either make 0 mistakes or he can make 1 mistake. But if he makes more than 1, that is 2, 3, 4, he fails the exam. That is what it says. Now let's see the questions. What is the probability that Tom will not make a mistake? Enter your answer as decimal. That is the first. Part B is, what is the probability that Tom will pass the test? Enter your answer as decimal. Now, this one over here, will not make a mistake, means what exactly? This is 1 mistake, 2, 3, 4. Will not make a mistake means 0. So probability of 0 is what we need to find for the part A. So it's directly given 0.11. It's very simple. But this one over here, what is the probability that Tom will pass the test? So he can either do 0 mistakes or he can do 1 mistakes to pass the test. So it will be probability of less than or equal to 1, because it can be 1 or 0, so it's less than or equal to 1. So add these two probabilities, basically 0.11 and 0.2. The answer is 0.31. If you're not understanding to write this, it's fine, whatever comes to your mind, because it's very easily understood. You should not make more than 1, so you just add the probability of 0 and 2 and you will get the answer. So that's how we solve this. Let's see another problem over here. Anna works as an operator in a call center. The table shows the possible number of calls Anna may receive during a 20-minute interval along with their corresponding probabilities. Now we in a 20-minute interval, this is 0 number of calls is 40% chances, 1 call is 10%, that's 0.1, 2 calls is 0.15, and 3 calls is 0.05. So whenever you take an interval of 20 minutes, this is the results. It's only for 20 minutes. So now let's see, what do we have to find? Fill in the blanks with the correct numbers. If your answer is not a whole number, enter it as a decimal number. The probability that Anna receives 8 calls in 20 minutes is equal to, now 0 is 0.4, 1 is 1. Over here, can you see anywhere 8? It's not given, so that's beyond the scope of this problem. So we just don't write anything over here. It's 0. Now the probability that Anna receives at least 3 calls in 20 minutes. Okay, this we can solve easily. And then probability that Anna receives less than 4 calls in 20 minutes. Okay. Less than 4 calls and at least 3 calls. They are two different things. Probability of 8 calls, not mentioned, it's 0. Now, what is this at least 3 calls? At least 3 calls means 3 or more. So now, one second. Here, what you can do is, you can add these 3 up and subtract from 1. So this is one way to solve, because look over here at the probabilities 0.4, 5, 6, 7. Only 0.7 is there. That means there is 4, 5 and more, right? It's not mentioned over here. So then what we do is, this is very important. The probability that Anna receives at least 3 calls means it can be 3 or more. It can be more than 3 as well. So these cannot be there in this particular probability. These 2, 3 over here, 0, 1, 2 cannot be there. So let me add this. This is 0.4 plus 1 is 0.5, 0.65. So this much probability cannot be there. So 1 minus 0.65, that is, which I have to exclude, will be the answer, that is 0.35. Yeah. So this is how we get this answer. I hope this is clear. Try the last one by yourself and then look for the answer, which I'll solve now. The probability that Anna receives less than 4 calls in 20 minutes is, over here you need to just add them all up. So since four less than four they are mentioned, they have not given any detail of 4 or 5, but we know there is about 0.3% over here, but we can't solve it anyways. But now we are less than 4. That means 4 is not included. It's 0, 1, 2, and 3. Add them all up. This much was 0.65 plus 0.05 would be 0.7. So the answer for this last one is 0.7. So this is how we solve probability models problem. Now another last problem over here. This is another interesting one. If two spinners shown in this figure, in the figure below, are spun simultaneously. See, now this is very, very crucial. Whenever there is two things that's happening simultaneously, it's not that easy because you need to draw it out. You need to draw the sample space over here. Now, enter your answers in fractions in the lowest form. First is part A. What is the probability that the two spinners land on sectors marked with the same number? What is the probability that two spinners land on sectors marked with different numbers? Okay. So now this over here, I will tell you how to do it. Very, very important. It also comes with die problem. You know, 6 faces are there of 2 dice. You will have to draw it. But now in this case, let's see what it is. You can start this anyhow. Over here, I've started from 0, 1, 1, 0, 0, 0, 1, 1, 0, 0. And the next one over here was 1, 1, 1, 0, 1, 0. 1, 1, 1, 0, 1, 0. So you can see I've just written them. Now don't worry about this. I can start, say, from here. 1, 1, 0, 0, 0. It's fine. Ultimately the answers will not change. Just the sample space changes. Okay, just this table will change. But anyhow, you'll get the same answer. So now you have written all these numbers from these two spinners, right? Now let us see when you can match and get same numbers. 0 and 1, are they same? No. X. 0 and 1, no. 0 and 1, no. 0 and 0 means they are same. See, lands on the same sector marked with the same numbers means it should be either 0, 0 or 1, 1. So now here 0, 0 means yes, it's correct. Tick. Now again 0, 1 is wrong and 0, 0 again, it's correct. Whereas now here 1, 1, it's correct, 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 and over here it's correct. It can't be 1, 0 or 0, 1. Same way we will do the rest of the table. You can see 1 and 1 always, it's when it's 1, 1, same numbers, it's marked, or if it's 0 and 0, it's marked right. That's a tick mark. So now for the first part, we need to find when they are on the same numbers, right? Let's count all the probabilities, all the possible outcomes for the same numbers. That is all the tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 desired outcomes. And what is the total possibilities? So 1, 2, 3, 4, 5, and there are 6. So 6 times 5, there are 5 possibilities over here and 6. Just multiply them, you will get the total possibilities. Or you can count all of over here, it'll be 30. So this is the answer. So we must keep it in fractions. So just divide by 2 over here, it'll be 7 by 15. So this is your answer for the part A. It's 7 by 15. Why? Because they want all the same numbers. Now over here, marked with different numbers means whatever is cross-marked. Since 14 is same, 16 would be different numbers because there are total 30, right? 30 minus 14 would be 16 by 30. So the different numbers would be 16 by 30 or 8 by 15. So this is how we can solve basic probability problems.